email? What does it mean?
Communication is the imparting or exchanging of information or news.
The single biggest problem in communication is the illusion that it has taken place.
Conversation is the oral exchange of sentiments, observations, opinions, or ideas.
Forbes Books Radio presents The Conversation with Clinton M. Padgett.
Joining me on The Conversation today is Dr. Franklin Chang-Diaz, a man that has accomplished so much, I could fill the first half of the podcast just listing the accomplishments. But let me at least give a few highlights. Dr. Chang-Diaz is an astronaut and scientist. He has a Bachelor's of Science degree in Mechanical Engineering from the University of Connecticut and a PhD in Applied Plasma Physics from MIT. He's been to space a record-tying 7 times. Born in Costa Rica, he was NASA's first Latin American astronaut to go into space. In addition to being in the NASA Astronaut Hall of Fame, he's a recipient of the U.S. Medal of Liberty, plus many other honors and awards. He's the founder and CEO of Astra Rocket Company, which is dedicated to the development of advanced plasma rocket propulsion. Dr. Chang-Diaz, thank you for joining me on The Conversation today.
Thank you. It's a pleasure.
I like to start off by thinking of my guest as kind of superheroes, and every superhero has a backstory. And I'm just curious, tell me about the journey of growing up in Costa Rica, dreaming of being an astronaut, and then actually realizing that dream. What was that journey like?
Well, it was a dream. It was a dream that really began with the opening of the space age back in 1957, with the launch of Sputnik 1. And I was one of many young boys and some girls as well at the time, mesmerized with the idea of going to space and exploring other worlds and other planets. In fact, we used to play as space explorers as we were little kids. And in my case, it was a cardboard box that I had made, built a spaceship out of it, and we had a couple of chairs, laying on their backs, and we would get in there and go through the whole countdown and go to and lift off and go and explore distant worlds and kill a few monsters and come back in time for dinner.
Now, you've been to space 7 times. You performed 3 spacewalks and helped build the International Space Station. Do you have a favorite experience or memory from that time?
Yes, actually, many vivid memories. But one that sort of stands out is I happened to be out on a spacewalk, and just by coincidence, we were heading towards the southern hemisphere over the South Pacific, and there was an aurora. The aurora australis, that is the southern lights as opposed to the northern lights. But to a plasma physicist, it's perfect. And we flew right through it. Wow. And I was out on the end of the arm, and I was just kind of letting it all be. Here I am, plasma physicist in space, flying right through the plasma of the aurora. What a beautiful sight. And it was just spectacular. I could not have a better seat.
I imagine you were just that kid again in the box and dreaming it all, except it was reality.
It was wonderful.
Now, your journey from astronaut to CEO of Astra Rocket Company is also incredibly fascinating. Can you walk us through what inspired you to make the leap from, say, space exploration over to the business world?
Well, it was just another adventure. My life has been a collection of adventures and experiments. Many of them have failed, but getting into the private sector was a completely different experience. I had been working for NASA for 25 years. Before that, I was doing research at the Draper Laboratory right after MIT. So I had never really been in the private sector in any way. I had to learn how to manage a company, how to deal with budgets and payroll and human resources and making sure that everybody was taken care of to continue this journey that we had started while I was at NASA. So the project was a NASA project that I had since I started at NASA. It just transitioned into the private sector. So we decided that, the government was going a little too slow for my taste, and I wanted to go fast. And so that's the reason why we transitioned into the private sector.
That's a perfect segue. So what do you consider the mission of your company to be?
Well, it's a very broad mission, but in essence, solving a fundamental problem in space travel, which is the transportation problem. We have really learned to travel in space with the chemical rocket. We are able to move around Earth orbit and go to the moon and back and so on. But we really need a paradigm shift to be able to truly have access to the deep space, these destinations like Mars and other points in the solar system that we really need to change our technology. And that is what I set out to do at Astra. Change that paradigm, moving to high power electric propulsion, plasma propulsion. But I'm talking high power. I'm talking hundreds of kilowatts at the low end to many multi-megawatts at the high end for human transportation.
I think I read somewhere that the output is as hot as the sun, or maybe twice as hot as the sun.
Yes, I mean when we talk about plasma, now we're talking about essentially a gas which is completely ionized, is completely stripped of its outer layers of electrical charge. The atoms have some of their electrons stripped off, and so you have essentially a kind of a soup of charged particles. And to do that, you need to get it very hot. So a plasma typically starts at about 50,000 degrees, and the plasma that we have in our exhaust here in the laboratory is over 5 million degrees. So clearly we don't handle it with any kind of material components. So we use strong magnetic forces, magnetic fields to be able to guide it and accelerate it and eject it in the right direction to produce rocket thrust.
Right. I saw that. That was one of the limiting factors was it melts everything. So your solution was the magnetic field, which I thought was really interesting because I'd also seen recently on a different show, I think I'm going to get this wrong because it's not my expertise, but I think they're doing fusion. And they also have to use magnetic containers to hold the energy.
Yes, that's correct. And in fact, the technology of the Vasimer engine, which is what we're developing, came from the magnetic fusion program, which is what I was doing before I joined NASA.
Okay.
So it's not something that I invented. It's something that I just borrowed from the fusion program and applied to the propulsion issue.
It was really interesting to research to have this call with you today because I also saw that I didn't realize chemical engines were limiting factors. So I learned about that. And then I also learned, you did say it's broader than just space travel because I also saw on your website where you're looking at maybe collecting space debris. And I know recently there was something in the news where I think made an explosion on an asteroid to try to shift the trajectory, and you have your own solution for that potentially. So your outcomes are quite large.
Yes, in fact, our company is really developing propulsion that can really fit on many applications. You mentioned some, such as collecting the orbital debris, which is a growing problem that we have in low Earth orbit, and also perhaps someday moving a large asteroid and conveniently position it in a place where we can do mining and extract its resources, but not so far away that it's so difficult to get there. So, and then of course we're interested in supporting the logistics, essentially the railroad that needs to be built between the Earth and the Moon to sustain a permanent presence of humans on the surface of the Moon. So all of these sort of spectrum of applications of transport, that's where we play.
Yeah, and I'm just parroting what I've already heard about you, so forgive me. But some of the advantages of what you're doing also is that it's, I think, 1/10 of the energy consumption is what you need to go 10 times faster.
Yes, the advantage of electric propulsion is exactly that you get a lot more bang for the buck, so to speak. You have a certain amount of propellant, amount of fuel that you're going to eject out the nozzle. And if you make it really, really hot, then you don't need to use it as copiously. You can be more frugal about the use of propellant. And so you don't need as much propellant. And so in the end, it's all about fuel efficiency. It's all about being able to, get more miles to the gallon, so to speak, and have more room for useful payload. And that's what electric propulsion is all about.
I guess at some point we'll talk about light years to the gallon, but right now it's still miles. So I also saw everybody wants to talk about Mars, and I think you gave the analogy somewhere that I saw where it's traditionally using conventional methods might take 7 months to get to Mars, but you guys can do it in less than 6 weeks.
Yes, and I have to be careful because I get in trouble.
Sorry,
because of my management here. But the answer is yes. However, you do have to have a power source that can power such a rocket, and that would be a nuclear reactor.
Right.
And it has to be not just a nuclear reactor, but it has to be a reactor plus the power conversion that allows you to convert the nuclear energy to electrical energy.
Right.
And then, of course, then you feed that into the rocket. So, you have to have all those components to make that mission so fast. But once you do, yes, you can go fast. And that is exactly the way we want to go to Mars. You don't want to go in 7 or 8 months. It just takes too long.
Yeah, it's fascinating. It's all the ancillary things I didn't think about, like the exposure to cosmic radiation is reduced, and the body, as when you spend so much time in space, there's some ramifications on that as well. So by shortening the amount of time you spend and travel, you reduce those parameters as well, which is interesting.
Yeah, and also just all the logistics of having to carry so much food and so much material to be able to sustain your crew. And the other important problem is the fact that the planets do move as you go. And if you take too long to get to Mars, by the time you get there, the Earth is on the other side of the sun. And now you want to come back. You have to wait for the Earth to position itself in the right place so that you can come back. And that ends up turning into a very long mission.
Right.
That you might not be prepared for.
Yeah, all the things you think about, I didn't think about, so that's all good. We kind of already touched on this, but just in case there's something you want to add, how do you draw on your experiences in both realms of space travel and also what you're doing now to drive integration and growth at your company?
Well, you have to always be thinking outside of the box, as the proverbial box, and we try to empower all of our team members to think freely. Now, every company has to have some organization, has to have discipline, but we do allow a certain amount of chaos. In some ways, chaos, if you let it go too far, then it's bad. But you do need some level of chaos to enable this creativity, all the juices to allow to flow, to people come up with ideas. And if you are able to control that, then your company will grow. Right.
So can you talk about a specific instance where communication was really important during a mission and how you and your team handled the situation? I mean, I can imagine that on these spacewalks and other things you guys did, building the International Space Station, communication is really super critical.
Communication is essential, and sharp, quick, and precise communication is super important. We had one case in my second flight, which was we were launching the Galileo spacecraft to Jupiter. We were flying on the Atlantis, and on liftoff, we experienced a problem of overheating of the shuttle, and the Galileo, which was an interplanetary probe, was powered by two nuclear batteries, plutonium batteries, and these things were continuously generating heat. You had to continue to cool them, otherwise they would overheat and overheat the whole ship. So we ended up in a very short sort of emergency condition on the way up to orbit, and we came within seconds of aborting the ascent and having to land in southern Spain or in northern Africa. I can't remember exactly which one was the landing site, but it was because of the communication, the correct and sharp and clear communication between the ground and our crew, that we were able to solve this problem quickly and get on with the mission. But it would have been a complete failure if we had not done proper communication and had not trained for it.
That's probably the key, training, so that you can handle bad situations.
Really important, yes.
What are some of the most important lessons you've learned about leadership and teamwork from your experiences in space, and how have you applied those lessons in your current work?
Well, mention again is empowering people. You really want to kind of get out of the way in many ways, not be a micromanager. You want to let people, express themselves in all of their capabilities and be proud of what they can do and reach their full potential. You also need to be not afraid of failure. Failure is something that inhibits people from trying things, and we here in our company have learned that in order to succeed, you have to be ready to fail. And you have to be willing to fail. And employees and team members are not going to be, penalized in any way by failure. You just have to be able to plan, and you have to be able to, explain why you chose the solution that you try to implement. But if you have a good story, failure is okay.
Especially on the ground.
Yeah.
So that actually leads into my next question. How do you balance that desire for innovation, because you're on the leading edge of what you're doing? How do you balance that innovation need for the risk taking for safety and reliability? How do you marriage those two things?
It's always a struggle, and I have to listen a lot to the team, to the members of my board, to all the people that have something to say on the mission that we are, trying to accomplish. You cannot be so narrow and completely set in your way that you don't listen to others. So you have to be very receptive to change and be willing to change when the moment comes. But it's a continuous struggle, a continuous balance. Being too daring, taking too many risks can kill the company. If you don't do anything and you don't move, you also can kill the company. So you gotta set things in motion, but not too much.
Well, that concludes part one of my conversation with Dr. Franklin Chang-Diaz, founder and CEO of Astra Rocket Company and former NASA astronaut. Coming up in part two, Dr. Chang-Diaz discusses the challenges ahead for his company and how he plans to overcome them.
The way we present this is that the difficult part is behind us. The expensive part is in front of us. That's kind of the way we see it. We've solved the basic issues of the physics, the unknowns in the physics of the engine. And now we're getting into the nitty-gritty of the engineering of the components, the materials, the various configurations. These are difficult problems, but they're not anywhere near as difficult as the ones we already overcome. So, but they are very expensive, because now we're talking about building something that has to fly, And those components are usually a lot more expensive than the ones that you just go buy at the Home Depot or at the local hardware store.
Thanks for listening to The Conversation. To find out more about Clint, go to clintonmpaget.com and pick up Clint's book, How Teams Triumph, Managing by Commitment, at Amazon. The Conversation with Clinton M. Paget is a production of Forbes Books.